All right. So 48's kind of a, got a lot going on here for a first question to look at. You never divide by a fraction. You always change this. Do you remember what this changes to on the right here?
Multiplication.
Multiplication by the reciprocal. Yeah. So I'm going to do that first here. And then you have some choices. So I'm gonna rewrite what's here, minus 14a squared, b squared, and then 6b cubed. Okay, so a couple options from here. You can cancel vertically. Okay, so like the b squared and the b squared and the b cubed, you can work that way. And if it's on the top, it's still considered vertical. Okay, but you may prefer to also work horizontal first. Like you might be like, hey, I want to multiply a squared times a or b squared times b. You have whatever authority you want to do that here. I like to cancel, but that doesn't mean that that's the right way to do it for you. How are you kind of working through these problems? Are you working them horizontally and then vertically to cancel? What are you doing first when you see something like this?
Vertically first.
Okay, and I like that. So here's what I see. I'm drawn more to the letters than the numbers. We'll get to the numbers in a moment, but like I see a b squared and a b to the 1, that makes b cubed, right? So those cancel with the b cubed down here.
Okay.
The a over here on the right cancels with the a on the bottom. Is that okay so far?
Yep.
All right. And then the a is left. Now you got it. So sometimes it's good to rewrite it. And I'm actually going to do that here because you can actually miss stuff because you're canceling. So I'm going to rewrite what's left over. Notice I'm not combining anything yet. So we still want to cancel. So next thing I'm drawn to are the numbers. Like, for example, I know that 3 goes into 15 and 21. And that's division by 3. And it's good to cross them out and rewrite the number. Then I notice, oh, well, 7 actually goes into 14. So those cancel. 2 up there, 1 down here. Your choice or not to write the 1. And then, oh, 2 goes into 6. So that's a 1 and that's a 3. And again, there's kind of a lot here. So if you need to rewrite it a couple of times along the way, that's fine. Minus a squared times 5, put that in front over 3.
Okay.
Any questions on that or anything you'd like me to clarify?
No, that was good. That makes sense.
Okay, I can always give you one like it if you need that, but we can just move on to number 51 if that's okay
Okay.
with you. All right. All right, your brother is actually doing a couple of problems like these, or that was a couple of weeks ago. We were working on some like 51, like this. So you will see this next year in your class. The problem here is that the bottoms are not the same. Okay, 4 is not the same as 3, and that means you can't do anything to the top. All right. So what I've been showing students here, and this is kind of extra, but there's what are called implied parentheses in the numerator, and meaning that you're supposed to know that they're there, but they're not written. And you might ask, well, why aren't they written if they're supposed to be there? It's like, well, it doesn't look as nice with them there, but when you're trying to work on things, it's easier. It's easier to see that. Next, your attention is drawn to the two bottom numbers, the 4 and the 3. What is the least common multiple? Okay, and you're getting bigger between 4 and 3. And if you're not sure what I mean by that, I can start writing a few out.
12.
12, yeah. Now, sometimes it is the case that if you multiply for the numbers together, you get the least common multiple, but it does not always happen. But you can always do that if you want. It's not always the best strategy. You really want the smallest one. So to get to 12, you have to take, in this case, you take, for example, this 3 on the right, and you multiply the top and bottom by the 3. On the left, you take the 4 from the left one, and you multiply the top and bottom by 4 on the right. It's your choice if you want to distribute in. It depends on your comfort level. Like if you're like, hey, you know, I've got it down, then go for it. If you like to show all the steps, then this is good too. So the idea here though is that because the bottoms are the same, you now can write one fraction, which you know, we're just reviewing here. And so I am going to distribute in 3 times 3x, 3 times minus 2. So it's 9x minus 6 plus. If this were a minus here in the middle, you would have to distribute that negative to this number. So just keep that in mind. But it's 4 times 5x, 4 times minus 1, so that's 20x minus 4. And then you combine like terms in the numerator.
Okay.
Okay, so like the 9x and the 20x, they go together. It's 29x minus 6 and minus 4. That makes minus 10. Then you bring down anything else that's left over, in this case, the 12. And for me, this is done. Sometimes there's like you would divide each of these by the 12. I don't think it's necessary, but you know, if there's a multiple choice, there might be a few variations on this in the test there. But I'd consider this done.
Right. Okay.
So not too bad. I mean, it probably looked harder than it actually was once you see, oh, I'm just making a common denominator and multiplying. I mean, you're not solving it. There's no equal signs. But if that's clear, 54 is really, really similar, except it's got letters instead of numbers. One of the things that you always do is you factor the denominators first, especially if they're unfactored like this one. There's an x that goes into both the first and the second term. And you notice I factor it kind of right below. That's just to save space. And I'll sometimes squiggle out or, you know, mark through that line. So I know that that's what I'm looking at. So it's actually the same thing as the previous problem. You're trying to find the greatest common factor between x and x plus 7. And sometimes it's easier, though, to look at it in terms of like, well, what is one missing that the other has? The one on the left has an x plus 7. The one on the right does not. So we're going to multiply the one on the right by x plus 7, top and bottom. You can always multiply the same thing on the top as the bottom.
Okay.
And our goal is to get a common denominator. That's still the reason we're doing all this. That hasn't changed. It's 3 times x plus 7 over x times x plus 7. It's out of the way. All right. Now, this time it's got a negative. So you really want to treat this as convert this into plus -3, or make sure you realize it's -3 that you're distributing in, not 3.
Right.
Because it's easy to miss the sign, especially in the second one. You see that all the time on standardized tests, where the second one, if a student doesn't remember to distribute in, that other answer is there and you feel like you got it right. But because the bottoms are the same, you can just focus on the top. 5 minus 3x minus 21.
Okay.
Almost done here. Combine like terms, the 5 and the minus 21, that's minus 16, minus 3x over x times x plus 7.
Okay.
Now, occasionally, we're done with this problem, but occasionally you can do some more factoring in the top, and sometimes you see a cancellation. It has to be a very hand-selected problem for this to happen. It's you know, very much a an outlier. It's unusual for you to get something like that, but figure I bring it up because you know you never know.
Right. Okay.
Okay, 57. So 57, I feel like 57 is really two problems in one. It's the top and then it's the bottom. And I tend to work these out horizontally. But you just work on the top and then work on the bottom, and then hopefully it works out. Maybe it does, maybe it doesn't. We'll see at the end. Okay. Now, probably by now, you can see that you generally just take what's, if they're like kind of unique in some way, the bottoms, you just take the one bottom multiplied by the other side, the other bottom multiplied by the other side. Okay. And that, that's what's going on here. We're going to take the X, multiply the top and bottom by X, take the Y on the right, multiply the top and bottom by Y. Okay. So this becomes 3y over xy minus 2x over xy. You generally put the x before the y. And I'm going to keep working on the top. Like, I'm not going to focus on the bottom yet. We'll come back to that. Since the bottoms are the same, it's 3y minus 2x over xy.
Okay.
And it's kind of as far as I can go. So wait for, something else to happen here. So now let's go to the bottom. The greatest common factor of the bottom is x squared times y. And again, it's just one of those cases where you take the one on the left and multiply it, the right by it, but it's both, it's top and bottom by x squared. And then similarly, you take the y and you multiply it by the left there.
Got it.
5y, x squared y, again, x comes before y, generally 7x squared over x squared y. Now, resist the urge to like try to cancel. Sometimes I see students do that, and like your goal is to make a common denominator. So you don't want to go backwards. 5y plus 7x squared. Okay. Now you might look at this and say, well, geez, it doesn't actually look that much better than what we started with. And I would tend to agree. Okay, but it's actually now more like what you did in problem 48. Just written differently. When you have big fraction bar here, you're dividing. So we're gonna multiply by the reciprocal. Okay, we're gonna take this 3y minus 2x over xy. Okay, and instead of this fraction bar, instead of dividing, we're gonna multiply by the reciprocal, x squared y over 5y plus 7x squared. And put a dot there instead of the x to make it clear.
Okay.
Okay. Now, again, there's implied parentheses, very important here, because it's easy to not remember that, but there's implied when there's a plus or a minus. Okay, you don't need them on the top right and the bottom left. You only need it when you're adding or subtracting. And if you go back to look at, this one, the reason we had implied parentheses is because there was an operator in the middle, addition and subtraction. That's when you need it. Okay, do you see anything that cancels in the top and the bottom here?
For the first one, the X and the Y.
So like, are you saying this y is that what you're referring to?
Yes.
Yes. Okay. And then the one of the x's goes with one of the x's up here. So you generally cross out the exponent when that happens. That means the x is left over.
Okay.
All right. So here we go. We got x left over on the top, 3y minus 2x over 5y plus 7x squared. There is nothing else that cancels here. Now, maybe you look at this and you ask, like, maybe, well, like, why don't the y's cancel or the x's cancel? We can talk about that, but maybe you already understand that this is it. There is nothing more that can be done.
Okay.
If not, we can go through that.
You can't cancel them. Is it because they're in equations already?
They're in parentheses. They're in parentheses. So like you've probably heard this like idea of terms and stuff like that. But when they're in parentheses, the whole thing has to be on the top and the bottom.
Oh.
The whole thing. Like, you have to see exactly 3y minus 2x down here, or vice versa. You have to see exactly 5y plus 7x squared up here. when it's in parentheses. When it's not in parentheses, when it's just floating, you just can cancel out.
Okay, got it.
All right, so we can move on to 63 whenever you are ready, or we say so.
Yep, I'm ready.
Okay. All right, so there's quite a bit that builds into doing a problem like 63. You know, like there's these kind of easier problems that help you to kind of know what to do here. So I guess I'm gonna just jump right in and hope that you have seen this before. It's really three separate problems. You're looking at like what happens to the 32, what happens to the x to the fourth, what happens to the y to the fifth. So for 32, you either do a factor ladder, which I guess is maybe something you've seen, or what I'd like is a tree. I guess the ladder's better now. I don't know. Both made of wood. I don't get it. Okay. Now, when you're taking a cube root, you look for triplets. So you have to have three that are matching to bring one out. And so you have that. You have 3 2s, so you can actually bring one out. Okay. So your answer, I'm going to put your answer up here. There's going to be stuff outside, and then there's stuff that goes inside.
Right.
Okay. All right. So the stuff that goes outside, we've got one of the things that goes outside too, but the 2s that are left over, they stay inside. So 2 times 2 stays inside.
Okay.
Any questions on that?
No.
Okay, we can always do another example like it. Now, like x to the fourth, you can make a factor ladder, but I think you can see that it's x times x times x times x. And similarly, you're looking for triplets, 3s. For each triplet, you can bring one out. So you can bring an x out, but there's an x left over and it must stay inside.
Okay.
I mean, it has to go somewhere. It either comes out or it stays inside. And the reason you're looking for 3 is because of this 3 up here. That tells you how many you're looking for.
Right.
Okay, so y times y times y times y times y. Those 3, you can bring one out. There's 2, those have to stay in. Okay. There is another approach here. This is usually what's taught, but there's another way I like to do it. So hopefully this is familiar. And then just a little cleanup. It's like, okay, you have to actually simplify what's inside. 2 times 2 is 4. Y times y is y squared. 2xy, 4xy squared, like that.
Got it.
All right, so we have tons of time left. So some options would be to do problems like this if you want some more. Another option is if you got more questions to send over, we can certainly work through more of those. We can always transition to SAT, ACT test prep as well. What would be best for you at this point?
Can we do questions with I?
Yes.
Thank you.
All right. So yeah, so I is the answer to this question. What is the square root of -1? And it's I. So there, just a brief moment here, there's the real number system, and then there's the complex number. I'm sorry, the imaginary numbers. I believe I'm saying this right. I tend to get this mixed up, but there's no overlap. So like some of the things that work in the imaginary work in the real and vice versa, but not everything. But this is the answer to this question, because in the real number system, there is no number that is the square root of -1. Like literally it means a number, or what most students see here is like there's no number that when you square it, you get to -1 in the real numbers. So that's why I have to go over to this imaginary. world. Right, so that's not super important, but it is the basis for what we're doing. So let's just say your first thing you might see is something like this. You'd see a problem that would say to solve x squared plus 16. And you would probably know, okay, I'm gonna subtract 16 from both sides. So I got x squared equals minus 16. Then you take a square root of both sides. And then it's plus or minus the square root of negative 16. Okay. So so now it's like, well, what is this? Okay. Well, here's what it is. It's the square root of negative 1 times 16. And you can break those apart. So there's a property that says a times b is the square root of a times the square root of b. So you can break this apart. It's the square root of negative 1 times the square root of 16. And finally, you see something that you know. You're like, oh, I know the square root of 16. It's 4. But what is the square root of negative 1? Well, it's I. Okay, so you pair these together. It's that x equals plus or minus for I.
Okay.
So we'll do another example, but you treat it just like you do if it were positive 16. It's just you add this little extra step where you have to deal with the square root of negative 1.
Okay. Okay.
Okay, so let's look at another one here. Let's say I ask you to solve 2x squared plus 18 equals 0. Okay. This was this is on a test or something. So to solve, you undo addition and multiplication, and you undo them in the order of this. So you undo addition and subtraction before multiplication division. So we're going to subtract 18, 2x squared equals minus 18.
Okay.
Then you divide by 2. So x squared equals minus 9. And this is the step where you have to know how to proceed, okay? So let's go back and look at the previous problem. What did we do once we got x squared equals a negative number? The square root of both sides, okay? So even though in the real number system you can't do that, you can in this one. You can take the square root of both numbers. Now it's still plus or minus square root of negative 9. And you break it apart. You say, oh, it's really the square root of negative 1 times 9. It's really the square root of negative 1 times the square root of 9. So what does this reduce to? Well, the square root of negative 1 is I. The square root of 9 is 3. You generally write the number before I, and that's your final answer.
Okay. Okay.
All right, so let's, I mean, this is one of the things that comes to mind. There's a lot of other types of problems. Is this what you were working on or something like it?
Yes, we did that.
Okay, so let me make one up here for you to try. And let's go 5x squared plus 125 equals 0. So I'd like you to solve for x, please.
Okay. Right. X equals plus or minus 5i.
You got it. Very good. Okay, so um, a more, well, not a more, another problem you might be asked to do is solving a bit more complicated quadratic equation. So it might say something like this. It might just say solve x squared minus 6x plus 12 equals 0. And you might at first glance say, oh, I got it. I'm going to try to factor this. Okay. And you make your list of 12 and you're like, all right, what, -1 and -12, -2, -6, -3, -4. And you're like, oh, none of these work, right? None of these add up to -6. Okay. And so you need to come up with another way. Do you remember what your kind of last resort is when it comes to quadratic equations to solve them?
Um, Wait, sorry, can you repeat that?
So like we tried factoring and factoring did not work, but there is something that always works. But I'm asking what it's called. It's the quadratic formula.
Oh, okay.
Okay. Do you remember the quadratic formula?
Yes.
Okay. Can you tell it to me?
X equals negative b plus or minus the square root of b squared minus 4 times AC over 2a.
Good. Okay. It's a tough one to remember, but it's needed here. All right. Can you tell me the value of A, B, and C from the quadratic?
A is 1, b -6, and c 12.
Nice. All right. So now you're going to substitute those into the equation. Now, my preference is to substitute, especially the negative numbers, substitute them in parentheses. So it's negative parentheses -6 plus or minus parentheses -6 squared minus 4 times A, which is 1 times C 12 all over 2 times 1.
Right, okay.
All right. Now the real challenge here is the inside part. This is where all the mistakes are made. By putting in parentheses, usually you've got a shot to avoid that. This is 36 minus 4 times 1 times 12, 48. So you've got inside 36 minus 48, which is, excuse me, -12. So it's on the outside here, it's 6, negative of a negative makes positive, plus or minus the square root of -12 over 2. And this is bad, right? Because you cannot take the square root of a negative number.
Right.
So what do? Well, you try to figure out how to reduce the square root of -12. So it's really the square root of -1 times the square root of 12. Would you agree with that?
Yes.
And the square root of -1 is I. 12 you can break apart. It's 2 and 2 and 3. So because there's a pair, you can bring one out. This 3 stays inside. So it's 2 square root 3. If that's unclear, we can do some more examples of that.
Could you do another one, please?
Yeah, I'll do that right after this problem. So let's just assume that this is okay for the moment. 6 plus or minus 2i square root 3. Now, we talked a little about this earlier. Like sometimes you do want to divide each of these by 2. And you might say, well, hey, I thought it was in parentheses. Like, yeah, it is. But that just means you have to share it to both. So it's 6 over 2 plus or minus 2i square root of 3 over 2. And so you cancel. 6 divided by 2 is 3, plus or minus 2 divided by 2 is 1, I square root 3.
Mm,
All right, now you ask a really important question, which is And I just thought that that was something you were already really good at, but let's get you faster, stronger, better at factor ladders. Okay.
Okay.
So let's say I wanted you to solve a problem like this, like x squared equals negative 24. Okay. So you would obviously take the square root of both sides, like we've been doing.
Right.
Okay. But now it's like, well, what do you do with this? Well, by now you've seen enough examples. You know it's the square root of negative 1 times the square root of 24. The 24 you have to reduce with a factor ladder. Now you start with prime numbers 2, 3, 5, 7. Usually you don't have to go much past that. Have you seen a factor ladder or a factor tree before?
Factor tree, yes.
Okay. Yeah. So I was working with a student recently, and I guess he's like, yeah, we don't make trees. I'm like, okay. So you start with 2, and you figure out what what multiplies 2 to get back to 24? It's 12. And then you try it again. You're like, well, it worked once, maybe it works again. And it does. And then you try it again, and yet it works again. Now on the leaves should be prime numbers. And there are. Okay.
Right.
And you're looking for pairs. Pairs come out. Stuff that's left over stays back inside. So the square root of 24, the 2 comes out, and the 2 times 3 stays on the inside. I square root of negative 1 is I plus or minus. So this is plus or minus 2i square root of 6.
Okay.
Okay. So let me give you another one here to try on your own here. Just a little bit more difficult, but totally doable. I want you to just reduce the square root of negative 80 for me, please. Square root of negative 80.
Okay.
And if you have questions, please ask.
Okay. So this one, if there's 2 pairs of 2 and 1 5 left over, would it be 4, plus or minus 4 to this, and then square root 5i?
So the I generally you want to put that before the root.
Okay. Okay.
Good. Yeah. So for every pair, there's more than one pair, you still bring one out, but then what's left over stays inside.
Right, got it.
Okay, fantastic. So now let's look at another one of these quadratics. Looking for someone that's not horrible here. They're all horrible now. We did kind of a nice one to start. All right, let's do this one. So let's do quadratic formula here on this. All right, so it would say to solve, and we're not going to try to factor this. Let's just say you now know it's a quadratic formula problem. A is 4, B is -3, and C is 2. And if you don't like the B squared, you can rewrite it as 4x squared minus 3x plus 2 equals 0. That's totally okay. Quadratic formula, opposite of B, plus or minus the square root B squared minus 4AC all over 2A. So in your problem, again, it's -3, put that in parentheses, plus or minus -3 squared minus 4 times 4 times 2 all over 2 times 4. I guess I haven't seen your handwriting. If you're, and I did not being critical at all, um, the most important part is that you get this one inside parentheses inside the root here, just really accurate. Some students just, they miss signs, numbers, so on. So just make sure you've got the numbers in the formula. That's the key to doing this right. All right, so now the part inside the parentheses, inside the root here, it's 9. 4 times 4 times 2, 4 times 4 is 16, times 2 is 32. So it's 9 minus 32, which is negative 23.
Okay.
So that's 3 plus or minus negative 23 over 8. All right, now we're not done. You cannot leave a negative inside the root here. Okay, so you got to break that apart. Now you might look at 23 and know that it is a prime number. If you're not sure, you know, you try numbers until you get up to like 5, 7, you know, like some number has to go into this, and you probably will eventually say, well, nothing goes into that. So if nothing goes into 23, you just leave it. It just becomes I square root 23 like that.
Okay, got it.
And that's okay. Sometimes that happens. Okay, let's have you try one on your own here. I'm looking for the solutions, quadratic formula. Please ask questions if you're not sure about how to proceed, and give this one a try. And then we'll transition to some other I topics that you might see.
Okay. Okay, so I'm not done, but I have 4 plus or minus the square root of negative 384 over 20.
Okay, so b squared is the minus 4 squared, minus 4 times 10 times 10, like that. Yes, and you do get all over 20. And yes, you get the square root of minus 384. So this one's got a bit more work to do to figure out, but you just start with 2.
Yes.
2 and 192, 2 and 96. And I'll let you keep going here. This one, I mean, it looks bad at start, but it really breaks down pretty nicely. So So if you want to just keep carrying that through and let me know what you come up with.
Okay. Okay, 3 pairs of 2.
Okay,
And
so
then,
6 comes out.
yes, and then a 2 and a 3.
Let me just double check that here because I'm seeing something slightly different here. No, I'm sorry. Actually, so 2 and 48, right? And then 2 and 24. Okay, yeah, you said that 3 pairs of 2s, right?
Yes.
So that's 2 times 2 times 2, I hope, which is 8. Is this what you have?
Yes.
Okay. And then this one additional step here, you do really want to take that 4 divided by the 20, the 8i root 6, and divide it by the 20. So you get 1/5 plus or minus 2/5 I root 6.
Okay.
Right. So we're gonna transition just a tiny bit with i's, just to some other problems you might see. So another problem you might see is like 3i times I plus 1 minus 4i times I minus 1, like this. And it would just say to simplify. So you have to be able to operate with I. Okay. 3i times I is 3i squared plus 3i. And like we talked about, you really treat this as minus 4i times each of these, minus 4i squared plus 4i. And this is where you got to remember something we said at the very beginning. Yes, the square root of -1 is I, but in this problem, you care about the fact that I squared is -1. These are separate. And what that means is wherever you see an I squared, you replace it with -1.
Okay.
But you don't replace the I with the square root of -1. So your answer will contain an I. No way to get out of that. So you have -3 plus 3i plus 4 plus 4i. And then you combine like terms. You say, okay, I can combine the -3 and the 4, that's +1. And then I can combine the 3i and the 4i, that's 7i. Have you seen problems like this?
Yes.
Okay. Any questions on what I just did here? I'd like you to try one.
No, I'm good. That made sense.
Okay, let's do one here. Won't make it any harder or easier, just different numbers here. Let's go minus 2i times I plus 2 plus 3i I minus 2. So go ahead and simplify that for me, please. And if you have any questions, of course, please let me know.
Okay. Okay, -1 minus 10i.
Yes, perfect. Yeah, let me show the steps here in case you want to look at this later in the replay. 3i squared minus 6i. Again, that I squared is -1. So that's -2 times -1 minus 4i plus 3 times -1 minus 6i. So that's 2 minus 4i minus 3 minus 6i. And like you said, -1 minus 10i. So last thought here is that the answers in this type of problem are always supposed to be written in this form, a plus bi, and that's the real part, and then the imaginary part, and then together it makes a complex part. Okay, and the reason I bring this up is because if you were to have given me the answer as -10i minus 1, you would be considered correct for me, but most textbooks would say nope, it's got to be in the other order. And I don't know why they're so specific, but that is just the case for problems like this one. So just keep that in mind. Make sure you put that real part first, then the imaginary part when you're working through these.
Okay, got it.